Now that we know our parent graphs, let's take a look at stretching and shrinking sine and cosine functions. And we have to recall that y equals f times x is going to be a vertical stretch or shrink of the graph y equals f of x by a factor of a. F of b of x is going to be a horizontal stretch or shrink by a factor of 1 over b. So stretching and shrinking sine and cosine functions. The graphs of y equals a times sine of b times x and y equals a times cosine b times x represent transformations of their parent functions. The value of a indicates a vertical stretch if a is greater than 1, or a vertical shrink if a is between 0 and 1, and it changes what is the amplitude of the graph. The value of b indicates a horizontal stretch if b is between 0 and 1, or a horizontal shrink if b is greater than 1, and it changes what's called the period of the graph. So the amplitude and period of the graphs, y equals a sine bx and y equals a cosine bx, where a and b are non-zero real numbers, are as follows. So the amplitude is the absolute value of a. It's the number in front. Just take away the signs. It's just going to be positive. The period is 2 pi over b. So let's take a look and practice this. So we're going to use 5 key points that partition the interval into 4 equal parts for the graphing of sine and cosine. We have 5 key points that you have to label. When we're graphing sine and cosine, we're only going to graph one period. Whenever you graph sine and cosine, these are the minimum amount of things that you need to show on your graph. We have y equals sine of x. We know that in this case, there's no a value in the front, so our amplitude is 1. There is no change in b, so therefore our period is 2 pi. When we know that our period is 2 pi, whatever that is, you go out 1, 2, 3, 4 to this point here. This is 2 pi. Then we're going to partition it into 4 equal parts. So 2 pi, half of 2 pi is pi. Half of pi is pi over 2. And then the last one over here will be 3 pi over 2. Another way to think about that is that this is pi over 2. This would be 2 pi over 2, which changes to pi. Then you add another half, that would be 3 pi over 2. If you add one more half, that would be 4 pi over 2, which is 2 pi. So that's how you would know how to partition it. Those are the 4 basic points that you have to show on your graph in order to get full credit on your graph of any sine curve. The other thing that you need to label is your maximum and minimum values on the y-axis. I'm going to label 1 up here and -1 down here. So that is what you have to have shown on every single one of your graphs. So just thinking about that for homework, your homework is actually, I'm not going to have it on big ideas because I want you to practice graphing. Because on big ideas, you get to just choose it. And I want you to practice on graphing. There aren't that many, so I want you to be able to learn how to start with whatever the periods start with and then partition it into 4 equal parts. So let's finish graphing sine. Sine, if you remember, at 0 radians, that value, sine, the y value is 0. The y value is 0. So therefore, at 0, we start at 0. Then when we go up, our y value equals 1, which is why it's 1 here. At pi, we were at -1, 0, so that y value is 0. Then at the bottom, at 3 pi over 2, -1, 0. 0, -1. That's 0, -1. Then we were at -1 down here. Then back at 2 pi, we're back at 0. So here's one entire period of the sine curve. That is exactly what I need to see for sine. We have 3 intercepts for a sine curve, 3 x-intercepts for the sine curve. Now for cosine, it's similar. Our amplitude is 1. The period is still 2 pi. So again, to do this, we go out 4, 1, 2, 3, 4 to 2 pi. Half of 2 pi is pi. Then half of pi is pi over 2. And then the last one is just a 3 pi over 2. Cosine. Thinking about our unit circle. What is our x value at 0 radians? Our x value is, label that, our x value is at 1. Then at the top, the x value is 0. On the pi, or the 3, at the pi, yes, at pi, we're at -1, 0, so it's down below. At 3 pi over 2 on our unit circle, that is 0, -1, so we're back at 0. And at 2 pi, our x value is back at the top at 1. So notice the pattern that always happens. Cosine starts at the amplitude, whatever your amplitude is. So if it's +1, it starts at +1. If it's +2, it starts at +2. If it's -2, then it's going to start at -2. And we'll see that a little bit later when we start to reflect our sine and cosine curves. So again, these are the bare minimum values, bare minimum labeling that you need to put on the sine and cosine graphs in order to get full credit.